Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers OCR Paper 3. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. This table shows the names and areas of 5 lakes. Not heard of many of these. Lagoda, Muero, Tana, Topozero, Victoria. Part A says write the area of Lake Mweru as an ordinary number. So here's Lake Mweru, and you can see that in standard form, you can see its area is 5.12 times 10 to the 3. Okay, so converting that into a normal number, you've got standard form power 3 here, which means I can either multiply it through by a 1 followed by 3 zeros, or I can just shift the decimal point 3 jumps to the right, can't I? So 1, 2, 3. So it's going to be 5, 1, 2 and an extra 0 then on the end. Okay, so that's 5,120. Part B says write the lakes in order of their area, starting with the smallest. Okay, well the one which is the smallest is going to be the one with the lowest power, isn't it? Because that is going to be the smallest magnitude. So this one here with the 2, that is going to be the smallest. So Topo 0 is the smallest. Okay, next power of 10 up is 3. So 10 to the 2 is hundreds, isn't it? And 10 to the 3 is in the thousands. So both of these lakes have areas in the thousands. Now obviously 3,000 is less than 5,000, so Tana is going to be the next smallest, and then Mweru, because 3.2 is less than 5.12, isn't it? Mweru. Okay, and then I've got 2 lakes whose areas of the magnitude 10 to the 4, which is in tens of thousands of square kilometers, isn't it? So out of Lagoda and Victoria, you can see Lagoda's got 1.81 and Victoria's got 6.89. So Lagoda is the smaller of the 2 and Victoria is the largest. Ladoga next, and then Victoria. Okay. Part C says calculate the difference between the areas of Lake Ladoga and Lake Tana. Give your answer in standard form correct to 2 significant figures. Okay, so difference in mathematics means subtract, isn't it? So we need to take one away from the other. So we are going to be taking the smaller one away from the bigger one, aren't we? So which one is smaller? Ladoga and Tana. Tana is the smallest because it's 10 to the 3, and Ladoga is 10 to the 4. So I'm going to take the smaller one away from the bigger one. So that's going to be 1.81 times 10 to the 4 subtract 3.2 times 10 to the 3. Okay, now It's a bit hard to subtract numbers when you've got these powers, different powers on the end. But if I take a power of 10 out of 10 to the 4, so if I take 10 out of 10 to the 4 and leave it as 10 to the 3, and with that 10 I can multiply the mantissa part of the number and get 18.1 times 10 to the 3. So I've kind of taken a 10 out of the power and stuck it in with the mantissa at the front. Then I've got 18.1 times 10 to the 3 minus 3.2 times 10 to the 3. Now these two are now of the same magnitude, so I can go ahead and I can subtract the mantissa parts from each other. So 18.1 subtract 3.2. Well, 18 take away 3 is 15, and 15.1 take away 0.2 is going to be 14.9, isn't it? So that's equal to 14.9 times 10 to the 3. Okay. Now I'm going to take the 10 back out of the 14 and put it back in with the 10 to the 3. So that's going to be 1.49 times 10 to the 4. Final answer does ask for two significant figures though, so I'm going to round this off and say that is 1.5 times 10 to the 4 as the final answer. A is a common factor of 72 and 120, and B is a common factor of 6 and 9. Work out the highest possible value of A over B. Okay, so this fraction is going to be its biggest when A is at its maximum value and B is at its minimum value, isn't it? Okay, you'll get a bigger number if you divide a fraction by a smaller denominator. So let's take B to start with then. I think that one's going to be easier. A common multiple of 6 and 9. If we want B to be minimum, we're actually asking for the lowest common multiple of 6 and 9. Okay, so let's think about the multiples of 6 and 9. The multiples of 6 are 6, 12, 18, and so on. And 9 is 9, 18, 27, and so on. So you can see we found our lowest common multiple already. 18 is there, 18 is there, so our LCM then of those two numbers is 18. So that's going to be my value of B. What about A then? We've got A is a common factor of 72 and 120. So let's list out the factors of 72 and 120. I tend to write them down in factor pairs. So 1 goes with 72. 2 goes with, well, half of 72 is 36. I think 3 must go into it then as well. So 3 and 24, is that? 3 and 24. 4 and what? 4 and, that's got to be 18, isn't it? 5, no, 6. Yeah, 6 goes into it. 6 and 12. 7, no, 8, yes. 8 goes with 9. And look, I've met myself coming down the other way, so that's as far as I'm going to get. So quite a lot of factor pairs of 72. What about 120? We're going to have so many. So I've got 1 and 120. 2 and 60. 3 goes with 40. 4, yes, goes with 30. 5 goes with 24. 6 goes with 20. Also got a lot of factors. 7, no. 8, yes. 8 goes with 15. 9, nope. 10, yes. 10 goes with 12. And then I've got 11 in between. That's not going to be a factor. So that's all of them. Gosh, lots of factors for both of those numbers. So we want the HCF then of those two numbers. So we want A to be as big as it can be. So it's going to be the highest common factor of those two. So looking through my list, 72, no, 36 is my next biggest. That isn't on my list. 24, yeah, that's on my list. So look, 24 there, 24 there. So the HCF of these two numbers is 24. Okay, so what's the highest possible value of A over B then? Is going to be, so that was my A value, wasn't it? 24, and B is 18. So my highest value is going to be 24 over 18. Okay. Which I could cancel down, but I'm not sure I need to. So it could simplify to 4/3. Also an acceptable answer. The diagram shows the results to the nearest percentage of a survey of 1,000 motorists. Driverless cars. Good idea, 20% think it is. Bad idea, 34% think it is. And not sure, 45% think it is. Interestingly, they don't add up to 100%, do they? Right, work out the largest possible number of motorists who thought driverless cars were a good idea. So actually, this is to the nearest percentage. It's a limits of accuracy question, isn't it? So if it was 20% to the nearest percentage, it means it's been rounded off to 20. Now, the next percentage up would be 21, and the next percentage down would be 19. So the ones that round to 20 are the ones that are halfway between those two. So the limits are going to be 19.5 and 20.5. They're the ones that round to 20 to the nearest percentage. So work out the largest possible number of motorists who thought driverless cars were a good idea. The largest possible is going to be the larger of those percentages then, isn't it? So I'm going to be using this upper limit then, 20.5, to calculate. Now obviously 20.5 you round up to the next value up, 21, but it still is the boundary and is still the one we calculate with. So largest possible is going to be 1,000 times by 20.5%, which is 1,000 as a multiplier. That's 0.205, isn't it? So that is 205. Now, strictly speaking, if it was 205 exactly, that would round up to 21% and not down to 20%. So I'm going to subtract 1 from that and write my answer as 204, because I know that definitely will round down to 20%. Question 6. A shop sells the same milk in 3 different size cartons. The diagram shows the price of each carton. So you can buy it for 300 millilitres for 31p, 500 millilitres for 47p, or 2 litres for £1.96. Which carton is the best value for money? Show how you decide. Now, your kind of natural instinct would be the bigger one would be the cheapest, but shops, they're a bit naughty sometimes, and it doesn't always work out that way. So good to check. Now, to work out the best amount, we need to have a standardized amount. So it doesn't actually matter what that amount is. We could work out per milliliter. We could work out for a litre, or we could find something that it will go into. Now the strategy depends on the paper. This is the calculator paper, so it doesn't really matter so much what number you pick. If it's a non-calculator paper, I'd probably pick a number that they all multiplied into, like a common factor or common multiple of those, a bit like, you know, you do with fractions. I'd be looking at 300 to 500 and 2000 and coming up with an LCM of those. And then maybe scale them all up. But because I've got my calculator here, it doesn't really matter so much. I'm just going to make it like, I think maybe a litre. So that should be fairly easy to do for each of them, especially for the last 2. The first one might be a little bit harder, but anyway, we'll get there. There's no problem. Right, so let's have a look at the 2 litre one. So the cost for 1 litre of that then, what is the cost of 1 litre? So 1 litre is going to cost £1.96 divided by 2, isn't it? Because you've got 2 litres in there. So if I divide it by 2, I'll get the cost of 1 litre. So what's 1.96 divided by 2? 1.96 divided by 2. So that costs 98p for 1 litre. Okay. Now for the 500 millilitre, if I double that one, I'm going to get a litre, aren't I? So 1 litre of this one is going to be, what, 47p times 2 then, isn't it? So 0.47 times 2. That comes out to be 94p. See, supermarkets, you got to watch them. 94p there. And then the 300 milliliter one for 31p. This was a little bit trickier to do. 1 litre here. What I'm going to do is I'm going to take 31p. I'm going to divide it by 3. That will tell me the price for 100 milliliters, sorry, and then I'm going to times it by 10. So I'm going to basically find 10/3 of 0.31. So 0.31 divide by 3 times by 10. That should tell me the cost of 1 litre. That is £1.03 reoccurring. So that's just £1.03 to the nearest penny then, isn't it? Okay, so you can see now, because I've got the same amount for each one, I've got 1 litre there, 1 litre there, 1 litre there, then I can compare the prices quite easily. So I can see here that the best value for money is that one there, isn't it, 94 pence. Okay, so which carton is the best value of money? 500 milliliter carton is best value. Now it says show how you decide. I kind of already did that. I'm not going to rehash it again. You know, my argument is a mathematical argument, and I've written it out here, haven't I? This is my argument here. I don't need to rehash it again into words. My mathematical argument stands. Part B says a student only buys milk on a Saturday morning. They use 120 millilitres of milk each day. Any unused milk is to be thrown away at the end of the following Friday. Show that it is cheaper for the student to buy milk they need in 300 millilitre cartons than in 500 millilitre cartons. Yeah, so whilst 500 millilitre is the cheapest per milliliter, if you're going to end up chucking a lot of it away, then maybe it isn't the cheapest way for you to buy milk. Maybe it's better to buy the smaller one. Let's just double check that. So they use 120 millilitres a day from Saturday through Friday. So that's 7 days, isn't it? Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So their total milk consumption for the week then is going to be the 120 millilitres per day times the 7 days of the week then, isn't it? So 120 times 7 comes out to be 840 litres, 140 millilitres. Okay, so in order to have 840 millilitres of milk, then they're either going to have to buy 3 of those on any given day, or 2 of those. Okay, so that's enough, isn't it? 3 lots of 300 is 900 millilitres. Or I could do 2 lots of 500 millilitres, which is 1,000 millilitres. Either way, I've got enough milk for the week then, haven't I? Okay, now one less would not be enough. I suppose I could buy 2 of the 300 millilitres and 1 of the 500s, but I'm not sure that's not going to work out any cheaper, is it? So they're my 2 options. So either buys 3 lots of 300 millilitres, which is 3 times 31 pence, which is, what's that? 3 lots of 31, that is 93 pence. Or he buys 2 of the 500 millilitre packs, which is 2 lots of 47 pence, which comes to, I suppose you put 0.47 on there, 0.47 times 2, that comes out to be 94 pence, so it's a penny more expensive. Okay, so at the end of the day, he's chucking away slightly less milk if he buys the 300 millilitres one, because he's only wasting 60 millilitres, plus he's saving a penny. So that's the better deal then, isn't it, if he's going to be not wasteful and also saving himself some money. Okay, so I'm just going to conclude cheaper to buy 300 millilitre containers. The diagram shows a cuboid and its diagonal. And the formula to work out the length of the diagonal in centimeters is length of diagonal equals the root of a squared plus b squared plus c squared. This is one of those interesting extensions of Pythagoras theorem. So when you move from 2 to 3 dimensions, all you got to do is add in your extra length then to work out the length of the diagonal. Quite cool. So what do we have to do here? Work out the length of the diagonal where a is 8, b is 3 and c is 2. We just need to put those numbers then into the calculation and work it out. So length is equal to the root of a squared, 8 squared, plus b squared, 3 squared, plus c squared, 2 squared. So job for my calculator, root 8 squared plus 3 squared plus 2 squared. That gives me 8.77. Oh, two significant figures, 8.8. Okay, now part B then says work out the length of the diagonal in terms of A when B is 2A and C is 2A. Okay, so we've got to do the same thing algebraically now. So the length is going to be equal to the root of a squared plus b is going to be 2a, so 2a squared, and c is going to be 2a squared, like that. So how many a squares have we got then? I've got a squared plus 4a squared plus 4a squared, which gives me 9a squared, and the square root of 9a squared, well, the square root of 9 is 3, and the square root of a squared is a. So it gives me 3a. And obviously when you square root, you often get two results, positive and negative, but in this case, there is only one solution that's valid, isn't it? It's 3a. The diagram shows the scale drawing of a sandpit ABCD. It also shows the arc of all points in the sandpit that are 80 centimeters from the corner A. We're told that the scale of 1 centimeter represents 20 centimeters. A game is played by throwing a ball into the sandpit. Points may be scored when the ball lands in the sandpit. 1 point if the ball lands within the 80 centimeters of corner A, and 1 point if the ball is closer to side AB than to side AD, and 1 point if the ball is closer to corner A than it is to corner B. By completing the construction, find and shade the regions where 2 points can be scored. Show all of your construction lines. Right, now the first construction is already done for us, isn't it? So the one where it has to be within 80 centimeters from corner A, that circle has already been drawn. It's that arc, isn't it, there? Yeah, so you can see this one is 4 centimeters, which is 80, so that has already been done. So I'm going to move on to the second one, which says 1 point if the ball is closer to side AB than AD. Okay, so the construction that we need for the points that are equidistant from two lines is the angle bisector of those two lines. Okay, so what we're going to have to do is construct the angle bisector. Now normally I would put the compass at A first and do an arc that cuts both, but we've already got this handy arc already drawn, so I'm just going to use those 2 points to mark my cross in the middle to make the angle bisector. Okay, so that makes my job a little bit easier. So sticking on either end, we're drawing a little arc, and then where they cross, that is going to be where my angle bisector is going to go through. Okay, so the line I'm drawing are all the points that are equidistant away from those two lines. So clearly if I want it to be closer to AB, then I want it to be below that line there then. Right, next construction. The point of if the ball lies closer to A than to B. So the points that are equidistant from two given points A and B are going to be the perpendicular bisector of that line. Okay, so in order to draw a perpendicular bisector, I'm going to set my compass to a little bit over halfway between those 2 points. And I'm going to draw an arc with the compass based at B. Okay, a bit of a semicircle going on there, and then switch over to A, and I'm going to draw another semicircle. We should find that they meet in 2 places. Okay, it's a little bit off screen. Let me just push it up a bit. So drawing a line through where those 2 arcs crossed, that's going to be my perpendicular bisector. So all of those points are equidistant from A and B. Okay, so if we want the points that are closer to A, then I want the points to the left of that line. As I said earlier, if I want the points that are closer to the line AB than the points AD, then I want those below the angle bisector. Okay. Now in this case, I then want the ones outside of the circle then, because if it's inside the circle, it'll be worth 3 points. But I want to highlight the ones that are just worth 2 points. So inside the circle would meet all 3 conditions, and then they'd be worth 3 points. Now, is there any other place which is worth 2 points? This one here is, isn't it? Because that's inside the circle and closer to A than to B, so that's worth 2 points. What other regions have we got? This one up here is only worth one point because it's closer to A than B, but doesn't meet any of the other conditions. And the one down there is worth 1 because it's closer to AB than AD, and the one at the top is worth 0 because it doesn't meet any of the conditions. Right, so they're the 2 regions that I want, and I've shaded both, so that's job done. Let's move on. Question 11. Joe and Kyle share an amount of money in the ratio 7 to n. Joe gets 35% of the money. Work out the value of n. Okay, so we know that Joe to Kyle is in the ratio of 7 to n. Now, Joe gets 35% of the money, so what percentage would be left then for Kyle? Kyle's going to get the rest then, isn't he? So if I've got 100% and I let Joe have 35% of it, then Kyle is going to get 65% of it. Okay? Can you see that that is, well, the relationship between these 2 numbers, that's 5 times bigger, isn't it? Okay? So then n, if I multiply n by 5, I'm going to get 65. In other words, n then must be 65 divided by 5. 65 divided by 5 is 13, so n is 13. Question 11. Use trigonometry to work out the size of angle x. Okay, right, so trigonometry is a right angle triangle, so it's about SOHCAHTOA, isn't it? Is that how you remember it? Now, easiest thing to do is just label up the sides first. Here's my angle down here. So that means, well, that's the longest side, isn't it? So it's the hypotenuse. This 9 joins onto it, so it's the adjacent, and that makes the other side the opposite. So I have been given the adjacent and the hypotenuse, and I want x. So the ratio that includes the adjacent and the hypotenuse is that one there. Cosine. So let's write that out fully then. The cosine of an angle is equal to the adjacent divided by the hypotenuse. Okay, that's the full ratio that we need to use. So then let's sub in what we know. Cos, well, it's x in this case, not theta. Adjacent is 9 and the hypotenuse is 10. Okay, so the cos of x is 9/10. So then x is going to be the inverse cosine of 9/10. Okay, so that, reaching for the calculator, shift cos 9 divided by 10 comes out to 25.84, which we're just going to round off to 1 decimal place, 25.8. Diagram shows a triangular prism and a cube. The ends of the prism are right angled triangles with base 6 centimeters and height 12 centimeters. The prism is 18 centimeters long. The volume of the prism is equal to the volume of the cube. Find the surface area of the cube. You must show your working. Okay. Right, so we've got volumes of prisms here, and the volume of any prism is going to be a cross-sectional area times its height or its length, isn't it? Okay, it's the distance between their front and back face. Times height or length. Okay, it's the distance between their front and their back face. Okay, right, so our original prism, the volume of the triangular prism, what's that one then? Okay, what is the cross-sectional area? What's this area here? Okay, well, it's a triangle, so its cross-sectional area is going to have formula half base height, and then we're going to multiply it by the length between the front and the back face, then, aren't we? Okay, so that's half times the length of the base. The length of the base is 16, so base is 16. The height of my triangle is 12, so that's going to go there, times 12. And then the length of my prism is that 18 there, so that's going to go on the end. Okay, so I've got half times 16 times 12 times 18. Okay, so what's that then? 0.5 times 16 times 12 times 18. That comes out to be 1,728. Okay, right, so 1,728. So that must be the same then as the volume of the cube. That's 1,728 in there then. Okay, so then what is the length of this cube? Okay, so then cube length, it's just going to be the cube root of that number then, isn't it? If they share the same volume, I normally get the volume of a cube by multiplying the length by itself 3 times. So if I cube root that number, it should give me the length of the cube. So what is the cube root of 1728? That comes out to be 12 apparently. So this is going to have a length of 12. So then what's the surface area of a cube? Well, a cube is made up of 6 separate square faces, and each of those faces has an area of length times length, so it's going to be 12 times 12 then, isn't it? So the surface area is going to be 6 faces times the area of each face, 12 times 12. What's that then? So 6 times 12 times 12, that comes to be 864. So the surface area of this cube is going to be 864 square centimeters. Describe fully the single transformation that maps triangle A onto triangle B. Now, A and B are different sizes, so it's definitely going to be an enlargement of some sort. Now, notice that A is the larger one and B is the smaller one, and we want to find the transformation that maps the larger one onto the smaller one. So it's going to be an enlargement with a fractional scale factor. So we need to know what that scale factor is, and we also want to know where the centre of enlargement is. Now, to find the scale factor, we just need to find 2 sides that are the same and compare them. So let's have a look at that side compared to that one. This side is of length 3, this side is of length 1. So my triangle B is 1/3 of the original height, or the original length. So the scale factor is going to be 1/3. The next thing we need to know is the centre of enlargement. Now the easiest way to find that is to draw on some ray lines that pass through matching corners of your shape. So let's draw one between those 2 points. And let's draw one through those 2 points as well. You can see that these ray lines are converging on the origin. I could draw a 3rd one in as well, but actually I've already seen what the answer is. So they're all converging on this point here. So that's the center of enlargement. So to fully describe the transformation, I'm going to say that this is an enlargement with scale factor 1/3 and center origin. The straight line passes through the point 8, 1 and is perpendicular to the line for y equals 4x minus 2. Find the equation of the line given your answer in the form of y equals mx plus c. Okay, so from the line y equals 4x minus 2, then our gradient, which I'm going to call m1, is 4 then, isn't it? Okay, so our line is perpendicular. In other words, m2, our gradient, is going to be minus 1 over m1, the negative reciprocal of the original gradient, so that's going to be minus 1/4. Okay, so I've got the gradient already of my new line. All I need to do now is to find c, the intercept, don't I? Okay, and to do that, I'm going to use this point up here that it passes through. Okay, so first off, I'm going to say equation is of form y equals minus 1/4 of x plus c. So I've kind of created a partial equation by subbing in the m value I know of minus 1/4 here, look, and that just leaves me the c value to find, and I'm going to use the point to find it now. So line passes through the point 8, 1. So subbing those values into the line, that means this is 8 is the x value and y is the 1 is the y value. So subbing in y equals 1, and that is equal to minus 1/4 lot of x, which is 8 plus c. And then what's that then? So minus 1/4 lots of 8, that's minus 2. So I've got 1 equals minus 2 plus c. Adding 2 to both sides, you can see that c is equal to 3 then, isn't it? Okay. So now I've got the full equation. Therefore, equation is y equals a minus 1/4 of x plus 3. The amount spent on clothes by 40 boys and 40 girls in 1 month was recorded. The table shows information about the amount spent by the boys. Okay, and I can already tell from the table, this is a group frequency table. So again, group frequency, they've got the midpoint marked, so I'm guessing they're going to ask me to find that estimated mean. The mean for the girls was £35. Estimate the mean for the girls as a percentage of the mean for the boys. Okay, so obviously the first thing I need to do is find what the mean for the boys is. So as I said, the table is already set up for it. To find the mean from a group frequency table, or estimate the mean, the first thing you've got to do is work out the midpoints of each of the groups or classes. That's because you don't know, out of these, for instance, these 22 boys here, you know that they scored between 0 and 20. But you don't know the precise value, do you, of what they've got now, because the data's been grouped. So we use 10 halfway between them. 0 plus 20 divided by 2 is 10, as an estimate of what those 22 boys spent. Okay, so going down the list and working out the other endpoints, the midpoints. So 20 plus 40 is 60, divided by 2 is 30. 40 plus 60 is 100, divided by 2 is 50. And 60 plus 80 is 140, divided by 2 is 70. Okay, so they're the midpoints that I'm going to be using. So if I'm saying that 22 boys spent, well, I'm estimating £10 each, then between them, if I multiply those together, 22 times 10 is 220. Okay, I'm going to do that for each of my other values. 30 times 9 was that 270. 50 times 6 is 300, and 70 times 3 is, what's that, 210? Okay, adding that up, you can use your calculator if you like, but often it's easier just to do it in your head. So that's 0, and then 2, 7 and 1 is 0, carry 1, and I've got 2, 4, 7, 8, 9, 10. So that adds up to 1,000. Okay. You might want to double check it on your calculator, but I think that's right. So then the estimated mean then for the boys is going to be sigma fx which is this amount here, isn't it? The sum of the frequencies times their values, which is 1,000, divided by sigma f, which is this value here, the total sum of the frequencies. So 1,000 divided by 40. So what's that? I think it's 25, but let me just double check. 1,000 divided by 40, 25, yeah. Okay, so the estimated mean for the boys is 25. The mean for the girls was 35. Estimate the mean for the girls as a percentage of the mean for the boys. So if you're expressing one number as a percentage of the other, then the number that you are talking about first is the top number, and the number you're talking about second is the bottom number. So then the percentage, it doesn't look quite right here because it's a big one on the top, is going to be the mean for the girls, which is 35, divided by the mean for the boys, which is 25, and they're going to have to turn that into a percentage. Okay, so what's that then? So 35 divided by 25, that gives me 1.4, and times 100 is 140%. Okay, so the mean of the girls as a percentage of the mean of the boys is 140%. Oops, 140. Danny has a pack of 45 cards. Each card is either red or black. 1/3 of the cards in the pack are red. She picks 2 cards from the pack without replacement. Calculate the probability that Danny picks 2 black cards. Okay, so this is a probability, well, it's a dependent probability question, isn't it? Where we have 2 selections and the outcome of the second selection is dependent on the first. We know this because of the word without replacement. When you don't replace the object you select and you make a second selection, you're going to have a different number of things to select from, and you're going to have different amounts of each depending on your first selection. So it's definitely a dependent probability question. Now the best way to demonstrate this is using a tree diagram. Okay, so either we get red or we get, I can either use black. I'm just going to tend to use not red. So red or not red, red and not red for our second selection, red and not red for my second selection. Okay, so what are the probabilities here? So if 1/3 of the cards in the pack are red, that's going to be 15 out of 45 then, isn't it? 15 out of 45 are going to be red. So red 15, and not red or black, there are going to be 30 then, aren't there? Okay. So what's the probability of selecting a red card on the first draw? Well, you've got the 15 red cards and you've got a total of 45 cards. So the probability of not red or black is going to be 30 not red cards out of a total of 45 cards. Okay, so that's the first selection. Now the second selection, this bit up here is going to be different from this bit down here, isn't it? Because if I go up that first branch, it means I've already selected 1 red card. So I've got one less red card to pick from on the second selection. So the probability of getting a red second time around is going to be 1 less red card out of 1 less card, which is 44. Now, if what's the probability of getting not red? Well, I've still got 30 not red cards in the draw, but I've still got 44 because I've already picked one. Okay. Now, if I go down the not red branch, that means I've already picked 1 black card out, which means there are still 15 red cards to select out of a total of 44 cards. And how many not red ones? Well, if I picked a not red one the first time, then I've got 29 remaining out of 44 to pick on the second selection. Okay, right, so we want to work out the probability that Danny picks 2 black cards, which is the not red route then, isn't it? It's that route down there. So the probability of not red is 30 over 45 multiplied by 29 out of 44. Okay, what's that? So 30 out of 45 times 29 out of 44. I believe that comes to 29 out of 66. 29 out of 66, apparently. Okay, I think we're done. Question 13. Points A, B, C, and D lie on the circumference of a circle. Line AC intersects line BD at point E. Prove that the triangle AED is similar to triangle BEC. Okay, so similarity means same angles. So what we need to show then that the 3 angles in AED match the 3 angles in BEC. Okay, so can we do that? So where are these 2 triangles first? So triangle AED is this one. So we need to find the 3 angles of this one compared to the 3 angles of this one. Now obviously we don't have any angles written on here, so we're going to have to give them angles, I guess. We could call them X, Y, and Z or something, and then show that they're equal to each other. Okay, let's start with the angle at E, because that one's fairly straightforward, isn't it? So here, what we've got is 2 vertically opposite angles, haven't we? So these 2 vertically opposite angles must be equal to each other. So I'm going to start with that. I'm going to say angle AED is equal to angle BEC because they are vertically opposite. Okay, so those 2 are equal. So then we've also got angles subtended from the same point. If you think about it, angles A and B, so the angle up here and up here, these 2 have got to be equal to each other as well because they're subtended from the same chord or arc. So they're both subtended from this chord here or arc here, DC. So they're both subtended from the same chord. So I'm going to say that DAE is equal to CBE, and the reason is because angles in the same segment subtended from same chord. Okay, and then finally we could say the same argument for the other 2 angles at the bottom here then. So this angle here and this angle here, they're both subtended from the chord AB, aren't they, or from the arc AB. Okay, they're both subtended off that same chord. So those 2 got to be equal to each other as well. So that angle there is going to have to be that angle there. So we can say then that ADE, angle ADE, that is going to be equal to BCE angle for the same reason. So that means that all of the angles match. Therefore, all 3 angles in both triangles match. So must be similar. Okay, we've got x plus 2 times 3x plus a times bx plus 3, and that's equal to 6x cubed plus 11x squared minus 17x minus 30, and we need to find the values of a and the values of b. Okay, now I think what we're going to do here, we've got triple brackets, which I'm going to try and multiply out as best I can and then compare them with the other side to see if I can work out what the values of a and b are, using a technique called comparing coefficients. So I'm just going to start with one side. So I'm going to start with the left-hand side of this. I don't want to deal with everything all at once. So I'm just going to start with the left-hand side. So I've got x plus 2 times 3 times 3x plus a times bx plus 3. So I'm just going to ignore the last bracket and just kind of do FOIL on the first two brackets. So just multiplying that with that, that with that, that with that. So what I get is x times 3x, which is 3x squared, and then x times a, which is ax, and then 2 times 3x, which is 6x, and then 2 times a, which is 2a. Okay, so that's what I get when I multiply out those two terms. Okay, and then I need to carry on multiplying it out. Now I need to multiply everything in the first bracket with everything in the second bracket. Okay, so I'm going to start off by multiplying everything through by bx and writing it down first. So 3x squared times bx, that is 3bx cubed. And then I've got ax times bx, which is abx squared. And then I've got 6x times bx, that's going to be 6bx. And then I've got 2a times bx, which is 2abx. Okay, so I've multiplied everything in the first bracket by bx, and now I'm going to multiply everything in the first bracket by 3. Rather than writing a big long line, I'm just going to drop down the line, and I'm going to start doing it from here. So I kind of, you'll see why I'm doing it that in a sec. So 3 times 3x squared, that is 9x squared. And then I've got 3 times ax, that is 3ax. And then I've got 3 times 6x, which is 18x. And I've got 3 times 2a, which is 6a. Okay? Right, so now we need to kind of combine all those together. So you can see I've got terms in x, I've got terms in x squared, I've got terms in x, which is here, 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 and here, and then I've got a term in, well, a number on the end, which is our constant on the end. Now what I want to do is I want to compare that to this thing up here that we wrote and that we had up here. So that is all equal to 6x cubed plus 11x squared plus, right, all four of these are going to be, oh sorry, minus. It's going to come to minus 17x, and then I've got minus 30 on the end. Okay, so if you think about it, that 3bx cubed matches up with this 6x cubed. So comparing coefficients, we call it. Compare coefficients of, first off, x cubed. What's that going to give us? So the x cubed coefficients, I've got 3b on one and I've got 6 on the other. So if these two expressions are equal, then they've got to be equal as well, haven't they? So 3b has got to be equal to 6, which tells me that b is equal to 2. Okay. Now I could look at the second one, but that hasn't got any a's in it, so that's no good. So I'm just going to have a look at this one on the end. So I've got 6a, and that matches up with 30 down here, or minus 30 actually. So comparing the constants, we've got 6a is equal to minus 30. Okay, right, so that gives me a is equal to negative 5. So a was negative 5 and b was 2. Okay, now a lot of this work here was superfluous. In fact, all of this bit in the middle, look, all this bit in here I didn't actually use or need. Okay, so actually you could have just shortcut this by just thinking about what term delivers you the x cubed term, and just kind of thought, well, that times that times that is going to give me my x cubed term, and that's going to be equal to 6. And what term delivers me the constant at the end? Well, it's that term times that term times that term. So you could have done it that way and saved yourself a bit of work. I've kind of done it long. It's only worth 2 marks, but hopefully you can see why it is what it is and decide whether or not you want to kind of do a full method or just kind of focus in on the x cubed term or the constant term, and kind of do it a bit faster. Sophia is competing in the long jump competition. Her first jump is 5.25 meters. Her best jump is 8% more than this. However, her best jump is 10% lower than the winning jump. Work out the length of the winning jump. So let's just try and visualize that. I've got a 5.25 was her first jump. Her best jump was 8% above that, but as good as that one was, it was 10% less than the winning jump. So that was her best, and this was the winner. Okay, so let's work out her best jump first off. So best is going to be, well, it's a percentage increase, isn't it? So using our triangle final original multiplier, our final is what we're trying to get. Our original is 5.25 and our multiplier is, well, it's 100% plus 8%, which is 108%, which is 1.08 as a multiplier. So our final is equal to our original times our multiplier. In this case, the original was 5.25 times a multiplier of 1.08, and that gives me 5.25 times 1.08 gives me 5.67. So 5.67 is a very best jump. Okay, but the winning jump, well, this 5.67 is 10% lower than the original amount. So the winning amount is, well, the winning amount subtract 10% is 5.67. So I actually want to do a reverse percentage here. So for the winning one, our final is 5.67. It's her best one. Our original is what we're trying to find, and the multiplier is going to be 100% less 10%, which is 90%, which is 0.90 as a multiplier. So using again the triangle final original multiplier, this time we are looking for the original, and we're going to use final divided by multiplier to find it. So that is 5.67 divided by 0.90, which is 6.3 meters, so 6 meters and 30 centimeters. That's a long jump. She's nowhere near it. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Okay. Now, the most popular way for this to be taught, I believe, is looking at second differences and using a kind of a convoluted way of piecing those two together. So the second differences here, for instance, are going to be 11, 21 take away 38 is 17, 38 taken away from 61, that is 23, and 61 take away from 90, that is 29. Okay, and then so that's what we call the first differences. The second differences are the differences of the differences. So you can see that's 6, 6, and 6. Okay, So normally when people are taught how to do this, they're taught to find the second difference, take that value of 6 and halve it, and then that is going to give you your n term, 3n squared. And then you have to work out the rest. You have to kind of then work that out and take it away and all that sort of palaver. But actually there's a different way that you can do it that I want to show you. Well, maybe let's just finish this method off first, and then I'll show the alternative way of doing it, which I think is nicer. So 3n squared. So if n is, remember this is when n is 1, n is 2, n is 3, n is 4, n is 5. Okay, so this sequence, if n is 1, 3n squared would be 1 squared times 3. It should be 3. When n is 2, 2 squared is 4 times 3 is 12. When n is 3, 3 squared is 9 times 3 is 27. And then 4, n squared is 16 times 3, 32, 48. And then 5 is 25 times 3 is 75. So then you work out the differences between your original sequence and this sequence for 3n squared. So what's that then? So the difference is 10 take away 3 is 7, 21 take away 12 is 9, 38 take away 27 is 11, 61 take away 48 is 13, and 9 take away 75, that is 15. Okay, so now what we've got left with, I hope you can see, is a linear sequence. So this has got a common difference this time. It goes up in twos, 2, 2, 2, 2, which means it's got to do with 2n. Okay, but it's not quite 2n, is it? Because 2n would be 2, 4, 6, 8, 10, and we've got 7, 9, 11, 13, 15. And that is 5 more than 2n. Okay, so then we combine these 3 bits together to work out that the nth term then of this quadratic, therefore nth term is 3n squared plus 2n plus 5. Okay, so now the reason I'm not so fond of this method is that, you know, why 3n squared minus, do you even know why you have to halve it there? It's just kind of learning a way of doing something. You don't really understand why it is what it is. Okay, well that's the reason why I don't particularly like it. So we're basically teaching students how to do something. We're not teaching them why. When we're teaching this method, they rarely understand why you have to take the 6n, the common difference and halve it, and that gives you 3n squared. They don't really make the connection. So I tend to teach it a different way. I use it with the general forms of a quadratic. So if it's a quadratic sequence, then the general form of a quadratic is an squared plus bn plus c, isn't it? That's the general form of the quadratic, okay? Where a, b, and c are some constants, okay? Now, when n is 1, that's the first term of our sequence, isn't it? So when n is 1, then an squared plus bn plus c, I'm going to have 1 squared times a, that's a, plus 1 lot of b, which is b plus c, okay? And I know that that is equal to the first term of my sequence. It's actually equal to 10. Okay, now when n is 2, then an squared plus bn plus c, an squared, take n, 2, and square it, 4. I'm going to get 4a plus bn, which is 2b plus c. That is equal to my second term. That is equal to 21. Okay, and then when n is 3, n squared is 9, so that would be 9a plus 3b plus c, and that is equal to our third term, which is 38. So what we do instead with this, we kind of, and that's, you just kind of stop there. What we're doing is we're forming 3 simultaneous equations in a, b, and c, which we can then go on and solve simultaneously. Okay, now you might think, oh, simultaneous equations is horrid. Why would we do it this way? This is really complicated. But actually, this bit here is the same no matter what sequence, quadratic sequence you're given. You always get this. So the only thing that you have to do is kind of bolt on your extra terms that you've been given from the actual sequence to form your equations, and then the technique becomes very similar. So after you've done a few this way, it comes really, really easy. Okay, so I've got 3 equations in 3 unknowns, A, B, and C, which I'm going to go on and solve. So the first thing I'm going to do is going to take equation 2, and I'm going to subtract equation 1. So equation 2, this one, subtract equation 1, which is this one. So what's 4a plus 2b plus c if I take away a plus b plus c? So kind of taking those away, I'm going to get 3a plus b, and the c's are going to cancel. So I'm going to get 3a plus b, and that is going to be equal to 21 take away 10, and 21 take away 10 is 11. Okay, and then I'm going to do the same thing. I'm going to do equation 3 take away equation 2. So then I've got equation 3 is this one, equation 2 is the yellow one. So taking the blue one, yellow one away from the blue one. So then 9a take away 4a is 5a, and 3b take away b is b, and 38 take away 21 is 17. Okay, so now I'm left now with 2 equations in 2 unknowns. Okay, so that's my second step. And now what we're going to do is we're going to take one of those away from the other. So that's going to be in my equation 4 and my equation 5. And now I'm just going to take 4 away from 5. So equation 5 take away equation 4. What's that then? So equation 5 then is this one. Equation 4 is this one. So if I'm taking equation 5 and I'm subtracting equation 4, what do I get? That's going to give me 2a is equal to 6. So a is 3. Once I know a, I can then sub it back into one of either 4 or 5 here. So 3a plus b is equal to 11. So 3 lots of 3 is 9. 9 plus what is 11? That tells me b is 2. Okay, and once I know b, then I can sub all those back into the first equation. A plus b plus c is 10. So a plus b is 5, and then what do I have to add on it to get 10? It must be 5, so c is 5. Okay, so they're my solutions. A is 3, b is 2, and c is 5. Then going back to our original form, a squared plus b, an squared plus bn plus c, just got to sub those values in. Therefore, nth term is equal to 3n squared plus 2n plus 5. Okay, so this draws on your knowledge of solving simultaneous equations. You might think, ugh, that looks hideous, I don't want to do it that way, but I would recommend giving it a go, because it's always the same. When you're doing this, no matter what quadratic you're doing, you'll find that 90% of the method is the same for every question, and you just get quite good at doing it. Okay, so try it. I'm not saying you have to do it this way, but I'm saying I think it's a better method, and students who do learn it this way tend to do quite well at it. So yeah, give it a go or not. Question 16. The box plot shows the distribution of salaries for the workers at Bexbridge Biscuits, and we've got a box plot. Okay, so when you've got a box plot, the lower line here, this is Q1, this is the lower quartile. The line in the middle is Q2, also known as the median, and this one up here is Q3, the upper quartile. The whiskers then go out to the highest value in your data set up this end, and the lowest value in your data set down this end. Okay, so what is the median salary? The median then is Q2, it's this value here. So all we've got to do really is read off this value from our graph. Okay, so just reading down, you can see it's here on our scale. So what's that? This scale is 30,000 to 40,000, and I've got 10 divisions in between. So each one of those divisions is going to be 1,000, isn't it? So I make that 30, 31, 32, 33, 34, 35, 36, 37,000. So I think the median salary here is 37,000. Okay. Interquartile range is Q3, the upper quartile, minus Q1, the lower quartile. Okay, so I already pointed those out. So Q3 is this one up here, and Q1 is this one down here, isn't it? So Q3 on our scale, what's that? That's 43,000. And then Q1 is down here. That's at 21,000. Okay, then subtract one from the other, and that is your interquartile range. 43,000, subtract 21,000, that's £22,000. Okay, put a pound sign in. Okay, so that's the median and the interquartile range. Okay, part C, the following salary information is true for workers at Camford Cookies. So this must be some sort of dastardly rival to Bexford Biscuits. So what do we know about Camford Cookies? The highest paid worker earns 85,000. The lowest paid worker earns 20% of the salary of the highest paid worker. 25% of the workers earn more than £50,000. 25% of the workers earn less than £28,000. The median salary is £37,000. Okay, that should be enough information to work out our box plot then. You remember we needed to know 5 values, didn't we? We needed to know the Q1, the Q2 and the Q3 values for doing the box, and we needed the highest and the lowest to do the whiskers. So we know the highest, it's here. So that's the first value, 85,000. So that's going to be what we're going to have up this end, 85. Now the lowest paid worker earns 20% of the salary of the highest paid worker. So that's going to be, what, 0.2 lots of 85,000. So 10% would be 8,500. Double that is 17,000, isn't it? So the lower end is going to be 17k. And then what is our Q1? 25% of workers earn more than 50,000. Well, 25% down from the top. They're actually talking about the upper quartile there, aren't they? So this one here is at 50k. And 25% of the workers earn less than 28,000. That's going to be my lower quartile, so that's 28k. And the median salary is 37. Okay, so we've got all the values now that we need to plot. It's a good idea to work them all out first, and then you can draw your box plot with confidence then, aren't you, that you know all the answers. Okay, so let's mark those values on first. So the lower value was at 17,000. So 17,000, that's 20, 19, 18, 17 is there. Okay, so that's my lower quartile. No, sorry, my lowest value. My lower quartile, we said, was at 28,000. So 30, 29, 28 is there. Then we had a median at 37,000. 40, 39, 38, 37. And then we had the upper quartile at 50,000. Nice, easy one to draw. And then we've got the highest value at 85, the fat cat there at the top. So 81, 82, 83, 84, 85 is that one. Okay, so now I've drawn all the lines, I can form a box in the middle. And then I can draw my whiskers going out to my highest and lowest value. Okay, that'll do. Looks pretty good. part D says make 2 different comparisons between the distributions of the salaries at Bexbridge Biscuits and the salaries at Camford Cookies. Okay, now if I pull up both of the box plots that we've done, or the one that was given and the one that we've drawn, now whilst these distributions are clearly different, they do share a number of similarities. Firstly, they have the same median. It's £37,000. That's the same for both. And also, if you look at the interquartile ranges, they are both the same width as well. They're kind of in a different place, but they have the same width. So the upper bound, so the upper quartile subtract the lower quartile, and both of these gives you the same answer of 22,000. So whilst they are clearly different distributions, I'm going to write down what's similar about them actually, because I'm going to compare the interquartile range and the medians. So let's do the interquartile range first. So the interquartile range is 22,000 for both distributions. Indicating that the spread of salaries is similar, and I'm going to say the average salary in both companies is the same. So, and median equals 37,000. Okay, so the interquartile range is 22,000 for both distributions, indicating that the spread of salaries is similar, and the average salary for both companies is the same. Median is 37,000. Question 17. Here is a function. I've got function A. We've got an input, and then we add 14 and then times by 5 to get the output. It says the output of function A is x. Write an algebraic expression in terms of x for the input of the function A. Okay, that's quite unusual. Normally we say that x is the input. Now, we've just tried to turn things around a little bit here to try and confuse us. So if the output is x, so let's work backwards and find what we put in if we got x out. Okay, so if we had x come out, working backwards, so going kind of backwards through this function machine, at this point here, what must have I had so that when I times it by 5 I've got x? Well, I would have had to had x over 5, wouldn't I? A fifth of x. So when I times it by x, I would have got x back again. And then going backwards through the first box, that plus 14 box, and what would I have to add on to get x over 5? I must have had x over 5 subtract 14, so that when I added the 14 it would cancel out, leaving me with x over 5, and then when I multiplied by 5 I'd end up with x. So basically what we're doing here is we're finding the inverse function, aren't we? We've worked out what the inverse function of x is. So what is the expression we would get? We would get x over 5 minus 14. Okay? B, a number k is also input into function A. The output is also k. Find the value of k. Well, that's interesting. So if I take k and I feed it into this function machine, then after the first box I'm going to get k plus 14, and then after the second box I'm going to get 5 lots of k plus 14, aren't I? And what they're saying here is that the output must be the same as the input, so that must be equal to k. Okay, so I've got now an equation that I need to try in k that I need to try and solve, haven't I? So if I've got 5 lots of k plus 14 is equal to k, right, let's just first remove that bracket. So 5 times k is 5k, and 5 times 14, that's 70, isn't it? that must be equal to k. So then subtracting k from both sides, don't know why that came out in blue. What am I going to get? So that's going to cancel, leave me with 0. So I'm going to 5k minus k, that's 4k. So 4k plus 70 is equal to 0. Subtracting 70 from both sides, I'm going to get 4k is negative 70. And then dividing through by 4, what's that? Half is 35, half again is 17.5. K is negative 17.5. Okay, I think that's it, isn't it? So if I put k is negative, if I put negative 17.5 into this function machine, then negative 17.5 should come out again the other side. You could just double check that, just feed it through, add 14 to it, times it by 5 and see if you get negative 17.5 back again. The ratio of number of boys to girls at a party is 3 to 4. 6 boys leave the party. The ratio of the number of boys to girls at the party is now 5 to 8. Work out the number of girls at the party. Now, the ratio of boys to girls we're given as 3 to 4 to start with. But notice in the second part we're given the ratio of girls, well, the number of parts of girls is 8, which is twice as much as we've got here. So in order to compare the two more easily, I can scale up this ratio by a factor of 2 and rewrite it as 6 parts to 8 parts. Okay, so we're told that 6 boys leave the party. And then we've got a new ratio of boys to girls of 5 to 8. Now, notice that this 8 here and this 8 here are the same. So the number of shares for girls is the same. And the boys has gone from 6 to 5, so it's reduced by 1. So overall, we've reduced the number of shares of boys by 1 when 6 boys left. So I conclude from that that 1 share is equivalent to 6 students. So if we then take our ratio of boys to girls and times it up by a factor of 6, we will find the number of students of each type overall. So 6 times 5, there should be 30 boys, and 8 times 6 should be 48 girls. So we need to work out the number of girls at the party, which is this number here, 48. Girls at the party, 48. Question 19. 2 cylinders A and B are mathematically similar. Cylinder A has volume of 2,400 cubic centimeters and a height of 12 centimeters, and cylinder B has a volume of 750 centimeters cubed. Find the height of cylinder B. Give your answer correct to an appropriate degree of accuracy. Again, we've got a shape and space question and no diagram. So for me, first thing I'm going to do is quickly sketch what I've got. Okay, so I've got big cylinder equals cylinder, okay, which are mathematically similar. I know that this one is 2400 and this one is 750, and this one has a height of 12, and this one is got a height that I'm trying to find, so I'm going to call it H. Okay, so I've got my 2 diagrams. Okay, now when you've got 2 mathematically similar shapes, then the ratio of their lengths and areas and volumes are all related, aren't they? So the ratio of their lengths, let's say it was x to y, then the ratio of their areas is going to be x squared to y squared, and the ratio of their volumes is going to be x cubed to y cubed. Okay, so we've got Well, we know the ratio of their volumes because we've got the values we've got there. We've got 2,400 and we've got 750. Okay, so if we cube root both those numbers, we should be able to find the ratio of their lengths. Now let's just make this a little bit easy to calculate with. If we divide both sides by 750, then I make this second one 1, don't I? So 2,400 divided by 750, according to my calculator, is 3.2. Okay, so the ratio of their volumes is 3.2 to 1. Okay, so that means that the ratio of their lengths is going to be the cube root of 3.2 to 1, isn't it? So cube root of 3.2 to 1, cube root of 1 is just 1. So the cube root of 3.2, again according to my calculator, is 1.47 to 1. I'm just going to keep the full calculator display value for now though, because I need to use that. This is going to be the length, isn't it? The ratio of their lengths is going to be 1.47 to 1. So if I then take 12 and I divide it by our cube root of 3.2, I should be able to find the height of our second can then. Okay, our second cylinder. So 12 divided by my previous answer comes out to be 8.14. Okay, so what would be an appropriate degree of accuracy? These numbers up here are quoted to 2 significant figures, each of them, aren't they? So I'm going to round this one off to 2 significant figures as well. I'm going to say that that is 12 to 8.1. Okay, so my height then is 8.1 to an appropriate degree of accuracy, 2 significant figures, the same as the other in the question. Lucy makes 5-digit number cards using all of these cards: 3, 4, 6, 7 and 9. So how many different numbers greater than 50,000 can she make? Okay, so let's consider her choices. If she's going to make numbers bigger than 50,000, then there's a restriction on her first selection of her first digit card. She can only pick one of these 3 to start off with then. So she's got 3 choices for her first selection. For her second selection, doesn't matter which one of those 6, 7 or 9 she picks, she'll have 4 other choices for her next digit number. Then she'll have 3 choices for her next digit, and 2 and then 1. So the total number of selections that she's got is going to be 3 times 4 times 3 times 2 times 1, which is 72 choices. Question 21. The graph of y equals x squared is shown below for x lying between -2 and 2. Part A says find the equation of the image when y is equal to x squared is reflected in the line y is equal to 2. Okay, so the line y is equal to 2 is here, look. So line y is equal to 2. So if it's reflected in that line, then the points above it are going to be below it, and the points below it are going to be above it. Points on the line are going to stay on the line. They're what we call invariant lines, aren't they? So in other words, this point down here at 0, 0 is going to end up like that. And I'm going to get a graph. It's going to look something like that. So it's going to peak at 0, 4, and it's going to go through those same 2 points over there. Okay, now we've got like 6 different types of transformation that we need to know about, and none of them is reflecting in the line y is equal to 2. We've got reflection in the axes. We can reflect in the x-axis and the y-axis. We know what to do about those, but this is a little bit trickier. And actually what you think you need to do here is think about this as a 2-step transformation. Okay, so step 1, reflect in the x-axis to give you a graph that looks like that, and then secondly translate your graph upwards. So after you've reflected it, then we kind of move it up. Okay, so I think that's what's happening here. So it's a reflection followed by a translation like that. So we're reflecting it in the x-axis, and then we're translating it how many units upwards? It's going up from there to there. Look, it's going up 4 units. Okay, so we're translating it 4 units up, and we're reflecting it in the y-axis, or reflecting the y-axis and then transforming it to 4 units up. So taking our original equation, y is equal to x squared, we're going to reflect it in the x-axis first. So reflect in x-axis. What's that going to do to the equation? It's just going to put a minus sign in front of it, isn't it? So rather than getting y equals x squared, I'm going to get y equals minus x squared. Okay, so I'm going to put a minus sign in front of x squared. My function of x goes to minus the function in x. That's what a reflection in the x-axis does. Okay, and then once I reflected it, I'm going to translate it 4 units in direction of y. So in other words, my function is going to go to f of x plus 4. So I'm going to take the line y equals minus x squared and add 4 to it. So I'm going to get y equals minus x squared plus 4. Okay, so that's my new line that I'm going to get, y equals minus x squared plus 4. Now I could just write that slightly neater as y equals 4 minus x squared, using one less symbol, okay, which I think is what I'm going to do. And then finally it says describe the single transformation that maps the graph of y equals x squared onto the graph of y equals x squared plus 6x minus 5. Now taking that equation y is equal to x squared plus 6x minus 5 and completing the square, I'm going to get y is equal to x plus 3 all squared minus 9 minus 5, which comes out to be y is equal to x plus 3 all squared minus 9 and minus 5 makes minus 14. Okay, and that has got a turning point or minimum value at minus 3 minus 14. Okay, so if you think about it, my graph of y is equal to x, which normally has a minimum value at 0, 0, has now got a minimum value at minus 3 minus 14. Okay, so my graph now looks something like that. So that means that my graph has shifted down like that, hasn't it? So it's gone minus 3 to the right and it's gone minus 14 up. Now I could write that as a column vector translation. If I was going to write that as a column vector, I would write the vector minus 3 minus 14, wouldn't I? Okay, minus 3 units to the right, minus 14 up. So I could say then that this is a translation using vector minus 3 minus 14 like that. In triangle JKL, M is the midpoint of JK. Jn to NL is in the ratio of 3 to 2, and we're told that the vector KL is 7a and the vector N to L is 4b. Okay, work out the vector J to M in terms of A, B, give your answer in its simplest form. So what we need to do is we need to find this vector here then, isn't it? Okay, we need to find that one. What do we know? We only know this direction here and we know this direction here. So basically what we're going to have to do is to find J to K and then halve it to find J to M. Okay, I think that's what we're going to have to do. Now we've got some information up here that isn't in the diagram. First off, we've got that m is the midpoint of jk. So that means that this distance is the same as this one then, isn't it? Okay, so let's just mark that on. And we're also told that jn to nl is in the ratio of 3 to 2. So jn to nl, so this is 3 to 2 along here. Okay, so if this is in the ratio of 3 to 2 and nl is 4b, then if I divide that by 2 and times it by 3, it should tell me that j to n, then this part down here, is going to be 4b divided by 2 times by 3. It's going to be 6b, isn't it? That's going to be 6b. I'm just going to write that down, that if I've got, if n to l is 4b, and I know that j to n is 3/2 of 4b, then I know that j to n is 6b. And that tells me also that j to l is going to be j to n plus n to l, which is going to be 6b plus 4b, which is 10b. Okay, so I know j to l is 10b. I already know k to l is 7a. So then I can find an expression for j to k. So this distance all the way along here. Well, going the other way actually. So what is the vector jk then? Going along places that I know. I can't go direct because I don't know anything about that line yet, but I know the other route. So I know that I can get from j to k by going from j to l and then going from l to k. Okay, and I know that j to l is 10b because I just found it, and I know that l to k is going to be minus 7a. Okay, because I'm going against the arrow, aren't I? So it's negative. Okay, so j to k is 10b minus 7a. Now what we want to know is what jm is. And we know that jm is the midpoint of jk. So j to m is going to be half of the vector j to k then, isn't it? Okay, so that is going to be half of 10b minus 7a, which is going to be, just multiplying that out, I'm going to get 5b minus 7 over 2a, like, just going to write it like that, 7 over 2a, it's like 3.5a. So the vector I want, j to m, is 5b minus 7 over 2a. So we get to finish off the paper with a 5-mark algebraic fractions question. What joy. Okay, so we've got a complex looking pair of fractions multiplied together, and we need to show that it simplifies to a slightly nicer looking algebraic fraction. Okay, so we know about how to combine two fractions together normally. If I have a much simpler fraction like a over b times c over d, we would just say that, wouldn't we? We would say AC is equal to BD. We just multiply the top with top, bottom with bottom, and then we'd see if we can cancel anything out. That's exactly what we're going to do here. We're going to put all of this over into one fraction and then see if we can cancel anything. Okay, so let's start with 2w plus 4 over w squared minus 25 times w plus 5 over w squared plus 3w plus 2, and that's going to equal to something all over 1 divisor. So 2w plus 4 times w plus 5 over w squared minus 25 times w squared plus 3w plus 2. Now, can we cancel anything here? Just having a look at what's on the bottom of this, I've got we've got two quadratics on the bottom. Now the one on the left, this one here, is actually the difference of two squares, w squared minus 25. If you remember your identities,
then a plus b times a minus b is equal to a squared minus b squared, which is what we've got going on here. So that part there becomes w plus 5, w minus 5. The other side of it, this bit here, is a quadratic. Can we factorize it? So does it factorize into two brackets? Well, if it did, it'd have a w and a w there. I have two numbers that multiply together to give me 2 and add to 3. So w plus 2, w plus 1. And that is over w plus 5 that we can't do anything with, and 2w plus 4, which we can do something with. So this part here, look. So that bit was that bit there. That bit was that bit there. That bit stayed the same, and the 2w plus 4 can become, or we can factorize 2 out of that, and it becomes 2w plus 2. Okay, so that's the blue bit. So we've kind of gone through and we've done little bits to each of those expressions. So now what? Can we cancel anything top and bottom? So I've got a w plus 2 there, which I can cancel with that w plus 2. And I've got a w plus 5 there that cancels with that w plus 5. So they all disappear. So that leaves me with 2 over w minus 5 w plus 1. Okay? So what we've done so far is we've multiplied these two things together. Now we still need to multiply that expression with this other bit on the end here, that bit. So that's the bit we're going to do next. So 2 over w minus 5 w plus 1 times 3w squared minus 16w plus 5. What's that equal to then? Well, that is 2 lots of 3w squared minus 16w plus 5 all over w minus 5 w plus 1. Now, it would be very handy if that top quadratic 3w squared minus 16w plus 5 would factorize, and I can then cancel it out with another one of my factors on the bottom. So does that break up into two brackets? Well, if it does, it's going to have a 3w here and a w there, and the numbers are going to have to multiply to 5 and add to minus 16. So if we put a minus 5 in there and a minus 1 in there, then that kind of works, doesn't it? So 3w times the minus 5 would give me minus 15w, and the minus 1 times the w would give me minus w, give me minus 16w altogether. So that does work. Right, so then can we cancel anything now? Again, I've got a w minus 5 there and a w minus 5 there, so they can cancel each other out. And I'm left with, what's left? We've got a 2, we've got a 3w minus 1 over w plus 1. Now, is that of the right form? Let's have a look back. Show that it simplifies to aw plus b, cw plus d. We're almost there. I think what it wants then, to make it into that form, I just need to multiply out the top part. Seems a bit counterintuitive, but let's do it. 6w minus 2 divided by w plus 1. Now that seems to be in the form required.
Mr. T, he's the best, helps you ace every test. swirly snout.